Okay, guys, my name is Victoria Doherty, and we're going to have a little chit chat about significant figures and what they really are. So, now that we're all going to school to become scientists or engineers or even working in the medical profession, we have to realize that not all numbers are significant. And how do we determine whether they're significant or not? First of all, why do we care? You probably don't, but you have to remember that a lot of times we're going to be doing calculations based on measurements. And anytime you have a measurement, we don't exactly know what it is. We're limited by the instrument that we're using. All instruments have a precision or a limit to what they can actually measure. And so when we start looking at these values, we have to keep that in mind. Later on, we're going to talk about calculations with these significant figures, and it makes a big deal. In other words, those days of us writing every number that's on our calculator, that's done. And so why is this important? Because we have to limit what we report based on the certainty or the precision of the instrument that we're using. There is absolutely zero instruments in this world that know the exact value of any measurement. And so the limitations are part of what we report, and later on, part of what we report after a calculation. So, what is a measurement and how does this fit into significant figures? Well, here's a simple ruler. Okay, it's measuring a little bit more than 2 centimeters. And you know that. Okay, and so when anytime you do a measurement, we can only report what is known and one guess. In other words, I know that it's somewhere between 2 and 3 centimeters. That we can see. Okay, this is obviously 0.2, 0.4, 0.6, 0.8, and then 3 centimeters. And so it's a little bit more than 0.2. So I know it's 2.2, and then we're allowed one guess. This is typically an educated guess. Okay, so I'm going to guess this is a little bit more than half. So I'm going to say 2.26. It's a measurement, so my unit must be reported. And that's what we report. In other words, I'm not going to look at this measurement here and say, geez, guys, I think that I just measured this little blue stick to be 2.2628931. You look at me like I was ridiculous. And of course I would be. And so that's the whole theory behind significant figures. They're not numbers, they're measurements. And the second you stop thinking them as numbers and start thinking them as measurements, significant figures starts to get a lot easier. So let's talk about identifying significant figures. Okay. The easy one is that all non-zero numbers are significant as long as they're part of a measurement. Okay. I have 62.52 mils. It says 4 significant figures because it's got 1, 2, 3, 4 non-zero. Okay. 7.89 grams per mole. This is maybe something I calculated after a limiting reagent calculation. Okay. And so this would give me what? 3 significant figures. 32 psi, that's how much air you put in your tire. Okay. 2 figs. And 1 microliter only has 1 significant figure because it only has 1 non-zero number. Okay. And again, remind yourself, because we're going to start doing measurements. Every single one of you can probably look at this and say, I've got 4, 3, 2, 1 sig figs. So you have to carry those significant figures through calculations. Okay. What about zeros? Well, zeros fall into 2 different categories. Oops, we're going to do this calculation first. So we're going to count how many significant figures are in this following number. Pretty simple. I have 2 non-zero number, 4 non-zero, 2 is a non-zero. We've already had this conversation, and 3. So 1, 2, 3, 4, 5. 5 significant figures. And so SF is the abbreviation for significant figures. Okay. You don't count the scientific notation afterwards. That's simply there to tell you what the magnitude is. And you can actually take this and convert it back into a non-scientific value. We'll talk about that later when we start talking about zeros. This is pretty simple. Okay. So let's talk about zeros because that's where most people have their issues. Okay. First thing we're going to talk about are so-called significant zeros, because sometimes significance or zeros are significant and sometimes they are not. The first one is literally a no-brainer. If I've got a zero in the middle of two non-zero numbers, of course it is significant. These are what we consider captured zeros. We have to put them there because if I didn't, are you supposed to guess how many zeros are between the 8 and 1? Of course not. So we write them. And so because they're part of the non-zero, because they're part of this non-zero number, 0 plus non-zero numbers, we count them as significant. Okay. Zeros at the end of a decimal and at the end of non-zero values. These are considered to be significant. Why? Again, if I'm telling you this is the number, I don't need those zeros there to tell you about how large this number is. What am I conveying to you is the certainty of my measurement. Okay. And in this case, if those zeros don't need to be there, because they don't, for me to tell you what the number is, I could very easily write, this is your pay for the week. Okay. And that's how much money you're going to make. And it's the same value as the number underneath it. The only difference is this is not how much you're getting paid. This is a measurement. And what they're trying to do is they're showing you, I spent a lot of money for this instrument and I'm showing off. Okay. And again, we talk about decimals. Decimals are kind of weird because sometimes we need them. Like we obviously need this decimal right here. But what about this decimal down there? Okay. I wonder why they put this decimal here. We don't need to know that there's a decimal here because there is an implied decimal in this value as well. Okay. And so when I take the time to write a decimal that doesn't need to be there, you wonder why. What I'm trying to do, again, is not convey the number because 110 is 100, I'm sorry, 1,010 and 1,010 are the same whether I write that decimal or not. Again, I'm trying to tell you that these three numbers I'm certain of, this is my one educated guess. And so that decimal is telling you where my certainty ends. And again, a lot of times we can take these and we can rewrite these in significant figures. I'm sorry, in scientific notation. So if I do that, I'd have to keep that number there, that last zero, to show you that this measurement has 4 significant figures. Okay. And then we'll get to the other ones later when we start talking about these so-called leading zeros. Again, remember, it's a measurement. It's not a number. Okay. It's a number only if you're not in college taking STEM classes. All right. So how many significant figures are in the following? Okay. So we have a non-zero 4, a so-called captured 0. We can't keep that out of our number. We have a 5. We have another captured 0. We have a 1, and then we have this trailing 0. Again, why does that trailing 0 then there? I'm trying to tell you something about the certainty of my measurement. So we count all these up. In this case, all of my numbers in this value are significant. And so I have 6 significant figures in this number. All right. So again, let's talk about it when zeros are not significant. Let's talk about it when zeros are not significant. Okay. We have to write zeros. Okay. Sometimes we just have to write zeros, even though we don't need them to convey the certainty of our measurement. For examples, we put zeros before decimals. Why? Well, MLA style says you have to. APA says you have to. People in the medical field, they write the 0 because it brings attention to the, they write the decimal, the 0 before the decimal because it brings attention to the decimal. If I missed this decimal and I gave this patient 2 milligrams instead of 0.2 milligrams, I could overdose the patient and kill them. This is 1 order of magnitude greater than the actual dose should be, 2 versus 0.2. And so that could actually kill somebody. Okay. Zeros after a non-zero number and before an implied decimal. So we looked at this number earlier, and I said that this 0 is significant because why? Because of this implied, because of this written 0. What about this implied 0? or decimal rather. I keep saying decimal or zero, whatever. What about this implied decimal? Okay, we didn't write it there. So what I'm trying to tell you is that my certainty stops here. These are my two certain numbers. This last number one is my guess. And so that zero is there. Why? Well, because I'm trying to tell you the magnitude of this value. Okay. I can't just write this as 101. I can't just write it for there like that and then expect you to know there's a zero there. Right? It'd be like, okay, I'm going to pay you $101 versus 1,010. That's a huge difference. Okay. And so we have to write the implied decimal to show you that this number right here has 4 significant figures. And it kind of goes back to the zeros after. Okay. Do they need to be there? No, they don't need to be there. Does that decimal need to be there? If we write it, then we're trying to say something about the significance. If we don't write it, we're just trying to tell you how big the value is. In other words, the magnitude. Okay. Zeros after decimals and after other zeros. These are not significant zeros. These are simply placeholders. Again, I'm trying to tell you how small in this case, this number is. And so we can easily drop all of my non-significant zeros and rewrite this in scientific notation. And so we drop this zero, this zero, this zero. This is to draw attention to the decimal. This is to tell us how small this value is. Then I have 1, 2, 3 non-zero numbers, captured zero, another non-zero number, and 2 trailing zeros that's showing off how much I spent on my instrument. And so this value here has 7 significant figures. Okay. So again, if the decimal's there because it has to be, in this case, it has to be. Okay. If the decimal's not there because it doesn't have to be, then that last zero is not significant. Okay. And whatnot. So again, let's do this problem here. How many significant figures are in the following? I have to put this there to bring attention to the decimal. These are telling you the magnitude of this so-called measurement. Non-zero, 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 and trailing zeros that don't need to be there, just to tell you that it's 0.005789 kilograms. I'm putting those those zeros there to tell you of my certainty of this measurement. Now, after this zero, who knows? And so the answer to this question is 6 significant figures. Now, not all numbers are significant. Not all numbers are counted numbers. And when you have counted numbers or so-called exact numbers, they have an infinite number of significant figures. And so right now, that doesn't really mean a lot, but when we start doing calculations with infinite numbers, we are not going to take the number of significant figures they have into account because they are infinite. Okay? In other words, I can count 1, 2, 3, 4, 5 students. There's 5 students. How many significant figures? An infinite number because why? It's a counted number. Are you sure? How do I know I'm sure? Well, I didn't measure the number of students with a so-called student meter. Okay, I counted. Okay, and so anytime you can count something, anytime you have exact conversions, those are considered to be infinite. Okay, here's some examples. How many people are in your family? Okay, it's an infinite number of significant figures. How many apples are in a bag? Speed of light. Okay, even though I only reported this many figures, it's implied that there's an infinite amount. Why don't we write all the values you say? Well, think about it. It's infinite. We'd be writing for a very, very long time. Well, infinitely. How many numbers in a mile? Okay, it's these so-called conversions. Okay, the number of protons in a carbon, that's a counted number too. 6 exactly. How many minutes in 1 hour? This is Avogadro's number. We're going to be starting to use this when you start doing your chemistry class. Oddly enough, 0 is an exact number. Okay, but not when it's part of another number. In other words, 0 just by itself has an infinite number of significant figures. When you start adding zeros into numbers, Well, it depends on the rules that we just talked about. Okay. So don't get confused there. If it's just 0, it's an infinite number of significant figures. Okay. Number of centimeters, number of pages in this book, pi. Okay. Even though we've only calculated it out to, I don't know, bazillion, gillion numbers past the decimal, theoretically, we can go on forever, infinitely. So it's also considered an exact number. Okay, so why numbers are significant and how we determine their significance is the end of this little tutorial. I hope it helped you. And I wish you guys luck.